Good morning, ladies and gentlemen. Welcome to this HPNet's 3-day training event on basics of micro hydro power generation and essential site assessment techniques to design a reliable, long-lasting scheme. This training event is in partnership with International Rivers, supported by Transboundary Rivers of South Asia, TROSA, and the Visions Initiative at the Wuppertal Institute for Climate, Environment and Energy. This event is part of HVNet's Social Enterprise for Energy, Ecological and Economic Development SEED accelerator designed for local practitioners. The recent IPCC report says that the globe is nearly a degree warmer than it has been at any point in the past 2000 years. That's a very scary situation. We can see the effects already across the world. Wildfires in USA, Canada, Europe, Turkey, floods in Germany, Japan, changing rainfall patterns all over the world. As the world is facing a severe climate crisis, a lot of attention is on alternatives to fossil fuels. Renewable energy technologies offer some hope. Of many types of RETs, hydropower is the oldest known RET and one of the most efficient options. A lot of large hydro schemes had been built over the last 200 years with huge storage dams. While the energy generated is renewable, the side effects are terrible in such massive large-scale projects. Fortunately, we can design micro or pico-sized hydro schemes too without the ill effect of large hydro. To do this, we need to change our approach to the design. Over the last few decades, a lot of work has happened on not only improving system reliability but also to simplify the manufacturing process so that this can be easily adopted by remote poor communities. In a typical project, cost of civil works can be as high as 40%, a significant part. So, a proper design is essential to minimize the costs and maximize the energy output. Repair of civil structures is very difficult. Try to break a concrete block. It has to be designed to last long or should be designed to be repairable easily. To design a good civil work, we need good site data. Poor site assessment will end up in bad design and will make the system more expensive. What we are going to do in these 3 days is we will list out all the essential components that make a microhydro work and what their roles are in the scheme. We will learn simple but very effective methods of site assessment like measuring flow rate, height, etc. We will also touch upon optimum locations and sizing factors for some components. Tomorrow, you will visit a site, apply the assessment methods, collect data. On the last day, we will work together to analyze and use the data to arrive at design conclusions. That is the overview of this training course. We have tried to make the course as interactive as possible. Breaks like this will help to reflect on topics covered. Please click on the link on the chat window and answer the questions. Let us quickly look at the answers. Different countries have different standards. So generally, a hydro scheme without a storage could be called microhydro. So all the answers are right. Answer for the second question is, more the data, better the design. Less margin for errors. Technical data like flow rate, maximum height difference. In our professions, we call it head, load demand, etc. These are technical. Then you have social data, which can be village population, number of households, what are the common facilities, income activities in the village, skill sets that are available, requirement of water for other users. These are some of the social data. Access to village, material availability for construction. These are some others.